No, no, no.
Good morning. Good morning, Kalpesh, Prasad. Runmay, good morning. How are you all? समजतंय सगळ्यांना? चॅप्टर रीड केला का? Okay. चला स्टार्ट करूया. होतील बाकी लोक जॉईन तोपर्यंत. कालच्या लेक्चरला इन अवर लास्ट लेक्चर वी स्टडी अबाउट addition and subtraction of binary numbers and subtraction by 2's complement. Okay, subtraction by 2's complement. Now today we are going to study subtraction by 1's complement. Okay, subtraction of binary number by 1's complement method, and then we try to simplify overall exercise, and today we try to finish this first chapter of paper 2, and then in next week we start chapter 1 of paper 1, that is instruments. Okay, so in our last lecture we studied the subtraction by 2's complement. Just I repeat the steps which we used for 2's complement method. That suppose we want to perform A minus B, where A is any 4-bit number and B is also any 4-bit number. Suppose A is any 4-bit number and B is also other 4-bit number, and we want to perform A minus B by 2's complement method. Then in first step we find the 2's complement of B, means which is the substrate. 2's complement of B. How to find 2's complement of B? First we find 1's complement of B, means replace all zeros by 1 and all 1 by zeros. In this way first we find 1's complement, and then we add 1 to that number or to that 1's complement. In this way we first find the 2's complement of B. Then we want to perform A minus B, but here we perform in second step A plus 2's complement of B. A plus 2's complement of B. Then third step, if there are two possibilities. In first possibility, there there may be carry present in the last MSB addition. If the carry present in 2's complement method, then we ignore that carry, and the meaning of that carry, presence of carry is, our answer is positive number. Okay, and we ignore that carry or do not consider that carry. Second one means, if second possibility is that there is no carry. If carry is not present, then we consider that our answer is negative and it is not a real answer. The answer is in the 2's complement form. So we have to find the 2's complement of the answer. जे answer आलेला आहे त्याचा 2's complement हे आपलं real answer असणार आहे, and that answer is negative if carry is not present. Okay, so Durgesh, welcome. Good morning. So now second method for binary subtraction. That method is known as a one's complement method. Strictly in exam, the question is like that: solve by 2's complement, or subtract by 2's complement, or subtract by 1's complement. Means you have to understand both the method of subtraction by 2's complement also, by 1's complement also. Good morning, Anvi. Okay, so subtraction. Okay, subtraction of binary numbers by 1's complement method. What is the step 1? Suppose, for example, is A minus B. A is your any 4-bit number, B is your another 4-bit number. Remember one important thing, that you have to make equal bits of A and B. Suppose, for example, A is 4-bit number and B is 3-bit number. Then suppose A is like this 1101 and B is 0. Sorry, B is suppose 01 is B1. At that time you may add zeros here because the zeros on left hand side are not significant. So this does not change the value of this number. 01 is also having value 1 and 0001 is also having value 1. So make equal bits before doing anything. In both the cases, in 1's complement also and in 2's complement method also, you have to make equal number of bits for both the numbers which we want to subtract. Okay, so here first step in A minus B, so find out in 1's complement method, find 1's complement of number B. Okay. What is step 2? Then subtraction is converted into addition. Therefore, A plus 1's complement of B means that is equal to A minus B. A minus B is nothing but A plus 1's complement of B. What is step 3? Suppose if carry present answer is positive, but here in this step for doing the subtraction by 2's complement method, we ignore that carry, we delete that carry, or we do not consider that carry. But here in 1's complement method, you have to add that carry in your answer. Again, the Meaning of that carry, presence of carry is same. That answer is positive in 1's complement also, in 2's complement also. Whenever carry present, answer is positive. Okay, whenever carry is present, answer is positive. But in 2's complement, we ignore that carry. But here in 1's complement, we add that carry and add carry to answer. Okay. Now step 4. If carry does not present, then your answer is negative. Your answer is negative. Answer is negative number, and in 1's complement form. Means if carry is not present, your answer is negative. Means you have to add negative sign to your answer, and that answer is not a real answer. You have to find out the 1's complement that are of answer, that is your real answer of your subtraction a minus b. Why I write all these things? Because sometimes the question is like that: explain subtraction by 1's complement. Explain this theoretically, you have to write like this. Okay, and another question is that simplify by 1's complement. Then at that time, all these steps, to write all these steps is not necessary. You directly simplify by following these steps. So both things you must know. That's why it is important to write all these rules. Okay. For example, suppose now your number A is 1011, B is 0101. Subtract by 1's complement. Okay. So right here in step 1, according to step 1, first we write like this. This is A and this is your B. A and B for our understanding. That is not necessary to write this is number A, this is number B. That is not necessary. Okay. So 10110101. So in step 1, in your answer, find first. We find 1's complement of number 0101. Therefore, 1's complement of 0101 is 1010. 1010. So we find, don't find the 1's complement of this number. After minus sign, which number is present? We have to find out the 1's complement of that number. So here this is the first step. Now what is the second step? Add 1's complement to first number. So what is first number? Therefore 1011 plus, what What is the ones complement? 1 0 1 0. Ones complement of this number is 1 0 1 0. Due to that ones complement, that negative sign changes to addition. So we add this number this time. Now we have to follow the rules of binary addition. 1 plus 0 is 1. 1 plus 1 0 carry 1. 1 plus 0 plus 0 is 1. 1 plus 1 0 carry 1. Now here carry 1 is present. Now here in ones complement method, we will not ignore that carry. We have to add that carry to this number. Add 1. That is known as the EAC. End around carry. End around carry. Therefore 1 plus 1 0 carry 1, so 1 and 0 1 as it is. Our answer is this one is our answer. Means whenever carry present, our answer is positive. What do we come to know? Our answer is positive and we have to add that 1 to this answer. Our answer is number 6. Now we try to verify whether our answer is correct or not by doing decimal subtraction. Our numbers are here 1 0 1 1 means 8 plus 2 plus 1 11. This number is 11. This number is 4 plus 1 5. So 11 minus 5. 11 minus 5. Answer is 6 plus 6. So here we get the number 0 1 1 0. 4 plus 2. Our answer is plus 6. Okay. Means this one is the example of positive answer. Now what happens when our answer is negative? For that, which rule we have to follow? For that, we will take another example. So you have to write down all these things simultaneously. Write down the steps. Today, Kirti. Where is Kanak? Divya. Where is Yamini? Yamini Devre is not present. Do you know Brunmay or Kirti about Yamini? Okay. Okay. Now, here we end theoretical part of first chapter. Now we try to simplify some exercise numericals. If all of you having textbooks, then raise your hand, just say like this. Okay. Then those who are not having textbook, just try to write what I am saying. Write fast. Now, before that, पहिल्याने बघाल काही first, second, third we already simplify. Second one, don't write, just try to understand. Second numerical is write the number of bits. MSB, LSB, number of nibbles, bytes in a binary number. Or you may write, those who are not having textbook, write down this, write a number of bits. Write a number of bits, comma, MSB, capital M, capital S, capital B, MSB, most significant bit, comma, LSB, least significant bit, comma, number of nibbles, and IBBLES, okay, and bytes, BYTES, in a given binary number. Okay. I try to share that exercise on WhatsApp or another app, your Telegram app. Okay. So write down that, write the number of bits MSB LSB. Suppose for example, not necessary the textbook number to write. Suppose we write the number like that. The binary number is this one. Suppose 1 0 1 1 1 0 1 1 1 1 0 1 0 1. This is your binary number. What they say? Find out the number of bits. How many number of bits are there? Number of bits is equal to, count that bits, 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12, 13, 14. That number having 14 bits. What is the MSB number? MSB, most, here the place of most significant bit, here the place of least significant bit. Here the place of MSB. This is your MSB. And this is your LSB. So, MSB, most significant bit is 1 and LSB also 1. Okay. Now, what about nibbles? Number of nibbles. Number of nibbles, NIBBLES. Nibble is any combination of 4-bit number is termed as a nibble, and a group of 8 bits is termed as a bytes, BYTES. So nibble means group of 4 bits. So how many number of nibbles? 1, 2, 1, 2, 3, and when they ask for nibble, then they give exactly equal numbers. Or means how number of nibbles, make a group of 4 bits. First, second, third, and fourth. How many nibbles are present? Group of 4 bits. How many groups present? 4 groups are present. Okay. And how many bytes? Number of bytes. BYTES, number of bytes is equal to a group of 8 bit is termed as, this is first byte, this is the second byte. So number of bytes equal to 2. Okay, number of bytes is equal to चालेल Prasad. Yes. Number of bytes is equal to 2. Now the next exercise, third question, solve the following. That we already all near about all simplify. Fourth question, encode the following decimal numbers into BCD code. Those who are not having textbook, now you have to write down page number 183. Like similar method, how we simplify in our 11. 11th ला सांगितलंय मी तुम्हाला कसं लिहून ठेवायचंय नोटबुक मध्ये. Write down the page number of textbook and exercise and number of that numerical. Okay, so write down page number 183. Exercise 4. Encode the following numbers into BCD code. Encode in BCD, binary coded decimal. And first is given 327.89. 327.89. And second one, that 15.423. As we study about BCD code, it is binary coded decimal and 0 to 9. Up to 9, all numbers are equal. Same like your binary number 0 to 9 means 0 in your binary system 0 0 0 0, 9 in your binary system 1 0 0 1. But in binary, 10 is written as 1 0 1 0. We said plus 2 is equal to 10. But that 10 is not allowed in BCD. In BCD, that 10 is written as for 1, you have to write 4 bits like this. And for 0, you have to write like this. This is the BCD code for this decimal 10. Okay, so encoding BCD and decimal numbers are given. Just write 4-bit number for every decimal bit or every decimal digit. So, suppose answer of 1, 327.89. For number 3, how you write 3? In BCD code 0 0 1 1. This one is the 2's place and this one is the 1's place. What about 2 0 0 1 0? What about don't put comma? So what about 7 0 1 1 1? Decimal point as it is. In place of 8, we write 4 bits 1 0 0 0, and for 9 0 0 0 1. This is the equivalent BCD code for this decimal number 327.89. Okay, agree all of you? Now the second example, in second example, 15.423. Write properly simultaneously with me. Second, 15.423. Therefore, in place of 1, you have to write 0 0 0 1. In place of 5, you have to write 4 plus 1 is 5. So, the 4-bit code for number 5 is 0 1 0 1. Point. What about 4? 0 1 0 0. What about 2? 0 0 1 0. For 3, the code is 0 0 1 1. This is the equivalent BCD code for number 15.423. 15 1 5 4 2 and 3. Okay, everyone understand this. The next example, pick. Add the following binary numbers. Two binary numbers are given 1010.1101 plus 101.01. Try to add these binary numbers. Now try to perform this addition at your own. And remember the rules, that rules for binary addition, that 0 plus 0 is 0, 0 plus 1 is 1, 1 plus 0 is 1, 1 plus 1, 0, carry 1, and 1 plus 1 plus 1, answer 1 and carry also 1. These are the rules of binary addition. But one thing you have to remember, that while doing this addition, you have to make all the bits equal. So add zeros here. You may add 0 here and make the equal number of bits for both the numbers. Without changing the value of that number, add zeros and make the equal number of bits like the first number, and then follow the rules of binary addition. So here, according to that, 1 plus 0 is 1, 0 plus 0 is 0, 1 plus 1, 0, carry 1. So 1 plus 1 again 0, carry 1. 1 plus 1, decimal point as it is, and 1 plus 1, 0, carry 1. 1 plus 1, 0, carry 1. 1 plus 1, 0, carry 1. 1 plus 1, 0, carry 1, and that carry in plain binary addition, we have to add this carry here. Okay? What is the value of 1 0 1 0 1 0 1 0 means 8 plus 2 10, and here also 4 plus 1 5, 10 plus 5 here about 15 point something. So the answer is your 16. Means in this way you may tally your answer whether we get correct answer or not. 16.000, because here 1101 is the decimal point and 0 1 here. When we add that 0 1 here. Okay, 1101, what is the value of that? 12 plus 13.30. When we add 1, then if you round up that second digit, then due to that one number is added here. So approximation, the answer is 16. That one is the right answer. In this way, you have to perform the addition directly by following the rules of binary addition. Okay. Write down this. perform subtraction using 2's complement. Now subtraction, just we study about 2's complement. This is our number A and this is our number B. Now what is the first step? We have to make equal number of bits of both the numbers. So this one is a 5-bit number, this one is a 4-bit number. So if we add zeros on this side, then the value of that number will change. But if we add 0 on this side, the value of that number will remain same and it makes no difference. But we have to make, before doing that subtraction, we have to make equal number of bits. Therefore, here we write that 1, 1, 1, 1, 0 minus 0 we add here 1, 0, 1, 0. Our number is only 1, 0, 1, 0, but we add 0 here. That makes no change in the value of this number. The meaning of this one is 8 plus 2, 10. This is the equivalent binary number of 10. This and 0, 1, 0, 1, 0 is also having value 10. So this is decimal. It is not necessary to write decimal values. When we tally the answer at that time, that conversion in decimal is necessary. That is for our understanding only. So by what they say, subtract by 2's complement. So in step 1, we find 2's complement of second number. Therefore, 2's complement of 0, 1, 0, 1, 0 is, here that 0 makes the difference. If you do not take that 0, then your answer goes wrong. So consider first step, you have to make equal number of bits for the both numbers, and then we find the 2's complement of that second number. 2's complement is 1, 0, 1, 0, 1 plus 1. So carry this addition 1 plus 1, 0, carry 1, therefore 1. Remaining numbers as it is. This is our 2's complement. Okay, this is our 2's complement. This is your first step. What is the second step? Now negative sign changes to positive sign when we make the 2's complement of this number. Then what is the second step? Add 1, 1, 1, 1, 0 with 2's complement. 1, 0, 1, 1, 0. Okay. So now we have to follow the rules of addition. 0 plus 0 is 0. 1 plus 1, 0. Carry 1. 1 plus 1 plus 1, answer is 1 and carry also 1. So 1 plus 1, 0. Carry 1. 1 plus 1 plus 1, answer 1 and carry 1. In 2's complement, that carry means we ignore that carry and our answer carry shows, means presence of carry means your answer is positive. and we ignore that carry, we delete that carry, we does not consider that carry. So our answer, real answer of this subtraction is this one. Now we try to find by decimal. So 1111 means 16 plus 8, 24. 24 plus 4, 28. 28 plus 2, 30. Means the meaning of this is 30. And this is your 8 plus 2, 10. Is 30 minus 10, your answer must be 20. So whether the value 20, what is the place value of this number? 16. What is the place value of this is 4. 16 plus 4, 20. Means we find right answer. Our answer is right. Don't write in exam. This is for your understanding. Okay, everyone understand this? All of you? Write down this. Right here. Now second. Now you try to simplify second and tell me the answer. Second, sixth. Solve by one's complement method. Solve by one's complement method. One's complement method. So make this addition 1 plus 1 0, carry 1 1 0 1. So carry not present. Carry not present means our answer is negative. Now by which method we simplify? By one's complement method. Carry is not present means answer is negative and it is in one's complement form. Our answer is negative. What do we have to write here? Carry. What do we predict? Carry not present means our answer is negative and in ones complement form. So we have to find the ones complement of answer. Therefore, ones complement of answer is 0, 1, 0, 1. Therefore, answer is equal to minus 0, 1, 0, 1. Our answer of this subtraction is minus 0, 1, 0, 1. Okay. So we try to verify our answer whether we get correct answer or not by using decimal subtraction. What is the value of this? This is our 8 plus 1, 9. 9 minus this is our 8 plus 4, 12. 12 plus 2, 14. So our answer is minus 5, which is equal to minus 5. And here also 4 plus 1, 5, we get right answer. Also, we get right answer. Also, we try to find same subtraction by using 2's complement also. The answer remains same. Okay, all of you understand this? Okay, this is exercise 6-2. Now, now 7, you have to write down that no calculations are there and try to understand that 7. Find the number of bits required to encode 58 elements of information. Now we study about different type of codes. We know 3 types of code: BCD code, ASCII code, and IPSID code. ASCII code is a 7-bit code. 7 bits means how many characters we able to encode? 128. 128 characters we able to encode. Now here what they ask, that 58 characters they want to encode. Then how many bits code is required? For that, you know that 2 raised to 0, 2 raised to 1, 2 raised to 2, 2 raised to 3, 2 raised to 4, 2 raised to 5. Here 16, 32 and here 64. So 8. 2 raised to 7, 64, 128. 2 raised to 8, 256. Okay. Means if the code is a 4-bit code, then how many characters we are able to encode? Only 8. If there is a 5-bit code, then we are able to encode 16 bits information. Okay. If there is a 5-bit code, then we are able to encode 32 characters of information. Now what they ask, 58 Now for 58, if you get 5-bit code that is insufficient, that is only for 32 bits, able to give the 32 characters to assign, and remaining 58 minus 32, what about that? So we have to use 6-bit code for 58 characters. We have to use 6-bit code. Then different combination of that 6-bit, we are able to assign 58 characters. Okay, like that second they ask, in that seventh they ask for 130 elements of information. Now whenever 130 elements of information, 130 number is greater than 128. So if we are having the code 7-bit code, then we are able to assign the 128 characters only. So 2 characters are remaining. That's why for 138 characters we have to use 8-bit code. We have for 130 characters, we have to use 8-bit code. Okay, do you understand? All of you understand or not? In this question, there are no calculation. You have to understand that how many bit code is required to encode the information, and the information having how many characters. The characters may be alphabets, may be number, may be signs. Okay, very good. Now we go to the next eighth example. Convert, this one is important. Eighth one is important. That is quite different. Convert following hexadecimal into BCD. Write down the heading as convert following hexadecimal into BCD. And number given E9A. In theoretical part of this chapter, we already studied different type of conversion, but there is no direct type to convert that any hex number into BCD. For that, we have to carry 2 steps. First, we go from hex to decimal number, hexadecimal to decimal, and then we convert decimal into BCD, because we know how to convert decimal number into BCD code. But we don't know how to convert directly hex number into BCD. For that, in first step, we have to convert that hex number into decimal number, and then that decimal number into BCD. So in the first step, write down properly, write down all these answers properly, because all these are the board questions. First we convert given number in decimal. So hex to decimal E9A. For conversion hexadecimal to decimal, remember that type 3 where I write here binary, decimal, hexadecimal, then how we go from hexadecimal to decimal. For that we have to multiply by 16 raised to 0, multiply by 16 raised to 1, multiply by 16 raised to 2. And here, therefore, we get E means what before F? E F. F means 15, therefore E means 14. So 14 multiply 16 raised to 2. Square of 16 is 256 plus 9 as it is 9 multiply 16. What is the meaning of A? A means your number 10. Therefore 10 multiply. Don't confuse here. 16 raised to 0 means 1. Don't take 16 here. 16 raised to 0 means 1. So calculate this. Calculate this. You also calculate. 14 6 are 84. Three six three eight. So 3638, right? Anyone get this answer? 3638. So equivalent decimal number of this hex number E9A means E9A to the base 16 means hex number is equal to 3638 in decimal. Now what is our question? We want to convert in BCD. Therefore 3638 in BCD. We know decimal to BCD convert. Easily we get decimal to BCD conversion. 3 for number 3 we write 0011. For number 6 we write 0110. Make here small gap. Then write for 3 0011 and then write for 8 1000. Here we write BCD. Okay. This is our answer. Means hex number is not directly converted to BCD. For that, first we have to convert that hex number into decimal. 3738. 3738. Sorry. Okay, right? 3738. Okay, first we convert that hex number into decimal and then the decimal number into BCD directly. Write down write down 4-bit number for every decimal bit. For 3, you have to write 0011. For 7, you have to write 0111. For 3, again 0011. And for 8, 1000. Prasad? Write it again. I do not understand what you want to say. Write down this one. Second example is also given that is for your homework. Similarly, you have to carry the step. That example is F4B. F means you have to take 15, 4 as it is. B means you have to take 11. Okay. Three, 7, 3, 8. Okay, 3, 7, 3, 8. Another example is F4B. F means 15, 4 as it is, B means 11. In this way, first you convert like this. 16 raised to 0, multiply here 11, B is there. 4 as it is, 4 multiply 16 raised to 1. And here 15 multiply 256. In this way, carry on. Similar by similar method and get the answer. Now next, solve by 1's complement method and subtract using 2's complement method. That we already simplify the similar examples. Okay, means 9 and 10 is for your homework. Shall I write here? मी इकडे लिहून देते तुम्हाला. These 2 examples are for your homework. Our lecture is on Tuesday, no? At 11 o'clock. At that time, we start new chapter of paper 1. So all of you are, I expect all of you would present and do your homework. If you are having any difficulty, then call me. Okay? Bye.